Jai Hind everyone. My name is Dr. Dibya Bharti. Today I am going to discuss topic two-port network. The subject name is Network Analysis and Synthesis. Subject code is KC303. So basically I am going to discuss the definition of port, what is two-port network, and then what are the parameters for the two-port network. Okay. So as we know, network is the connection of electrical and electronics element that may be closed or that may not be closed. Okay, so a circuit means they must form closed loop, but networks may not be closed. Okay, so a port means a pair of terminals. Okay, so as we know, so for each element, for each device, you can say there are two terminals, one positive terminal. We designate one terminal as positive and another terminal as negative. So pair of terminals are called as port. Okay, so first we will see what is two-port network, and then we will discuss the different parameters for analyzing the two-port network. Okay, so basically two-port network is a interconnection of network elements. Okay, so in which there are four terminals. Okay, there are four terminals. One pair of terminal is designated as input port and another pair of terminal is designated as output port. So usually we denote this two-port network with a black box representation. Okay, so this representation, this is two-port network. Okay, so we are not knowing that what are the elements in between this network. Okay, so we don't have the information that which network element is there in the circuit. Okay, so but two terminals will be there. Okay, so two terminals will be there in one part and two terminals are there in this part. Okay, so this pair of terminal is known as port. Okay, so this one terminal may be designated as input port and another pair of terminals may be designated as output port. Okay, so that's why this is called as two-port network. Okay, so there may be n port network. Okay, so what is the definition of two-port network? Is that it is the interconnection of network elements where one pair of terminal is designated as input port and another pair of terminal is designated as output port, is called as the two-port network. Okay, so usually we represent this two-port network with a black box representation. So this box type rectangular box representation is there for the two-port network. Okay, so this is the introduction about the two-port network, and now there are different parameters. Okay, so for analyzing the behavior of the two-port network. Okay, so like first is the Z parameter, second one is the Y parameter, then ABCD parameter, H parameter, G parameter, and inverse ABCD parameter. Okay, so this G parameter is the inverse of H parameter and this is the inverse ABCD parameter. Okay, so mainly there are four parameters only. Okay, so this G and inverse ABCD are the G parameters are the reciprocal or are the inverse of H parameter, and inverse ABCD is the inverse of ABCD parameter. So ABCD parameters, if you see, so there are mainly four parameters are there. Okay, so Z parameter, Y parameter, ABCD parameter, and H parameter. Z parameters are also known as impedance parameter. Okay, Y parameters are also known as admittance parameter. Then ABCD parameter. ABCD parameters are also known as T parameter. T parameter means transmission parameter. T parameters. T parameters. Okay, so this is also known as generalized circuit parameter. Okay, so H parameters means hybrid parameters. Hybrid parameters. Okay, Z parameter, Y parameter, ABCD parameter, and H parameter. So we will mainly focus on these 4 parameters. Z parameters are also known as impedance parameter or open circuit parameter. Okay, why they are called as open circuit parameter, that we will see in next slide. Y parameters are also known as admittance parameter, as well as they are also known as short circuit parameters. Okay, then ABCD parameters are there. ABCD parameters are also known as transmission parameter or generalized circuit parameter. Okay, so then H parameter or hybrid parameters. Okay, so why this is called as hybrid parameter, that we will discuss in detail in next slides. So let's start with, this is the all about the introduction that I had already discussed. So two port network has two pair of terminals. Okay, one pair of input, one pair at the input known as the input port, and other pair at the output is known as the output port. Okay, so this is the representation of the two port network. So there are four variables, as you can see there are four variables: V1, I1, I2 and V2. Okay, so this is the general convention that we designate the direction of current as shown here. Okay, so this is the representation for the direction of current. Okay, so here from input port also current are incoming towards the port, and from output side also currents are going towards the network. Okay, so this is the convention for representing the current in two-port network. Okay, so there are total four variables: V1, V2, I1 and I2. So two of these variables can be expressed in terms of other two variables. Okay, so thus there will be, if we see, two variables can be represented in terms of other two variables. So that means there will be two dependent variables and two independent variables. Okay, so there are total, if you see the possible combination, then 4C2, that means 6. Okay, so there are 6 possible sets of equation depending on the our consideration. So there are total 6 possible set of equation for describing a two-port network. Okay, so since there are 4 variables and 2 variables can be written with the help of 2 other variables. Okay, so that means 2 dependent and 2 independent variables are there, and if we see the possible combination, that means out of 4 we can select any 2. Okay, so 4C2, so that will be 6. So for that means there are 6 possible set of equations for describing the two-port network. Okay, so now see, these are the parameters that we had discussed here. So now first is the open circuit parameter or Z parameter. Open circuit parameter or Z parameter. Okay, so in Z parameter, what we do, we write V1, V2 in terms of I1 and I2. So here V1 and V2 are dependent on I1 and I2. Okay, so see, this is the equation: V1 equal to Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2. So in matrix form also you can write this. So in matrix form also you can write this as V1, V2, V1, V2 equal to Z11, Z21, Z12, Z22 into I1, I2. Okay, so this is for the Z parameter or open circuit parameter. So next is the short circuit parameter or Y parameter or admittance parameter. Okay, so for in case of Y parameter, we can write I1, I2 in terms of V1 and V2. So I1, I2 in terms of V1, V2. So I1 is Y11 V1 plus Y12 V2. So Y11, Y12, Y21, Y22. Okay. So this is V1 and V2. Okay. So I1, I2 can be written in terms of V1 and V2. Okay. Next is the ABCD parameter or transmission parameter. Okay. So ABCD parameter. So in case of ABCD parameter, we write V1 I1 in terms of V2 and minus I2. Okay. So V2 and minus I2. So V1 I1, sorry, V1 and I1 in terms of V1 I1 in terms of V2 and minus I2. So A, B, C and D. So it will be V2 and minus I2. Okay. So V1 is AV2 minus BI2. I1 is CV2 minus DI2. Okay. So then inverse transmission parameter. Okay. In case of inverse transmission parameter, what we do, we write V2 I2 in terms of V1 minus I1. Okay. So in that case, V2 I2, it will be okay. So V1 minus I1. Okay. So this is inverse T parameter or inverse ABCD parameter. So next is the hybrid parameter, matlab H parameter. H parameters. Okay. So in case of hybrid parameter, V1 I2, we write V1 I2 in terms of I1 V2. Okay. So H11, H12, H21 and H22. Okay. In terms of I1 V2. Okay. Then G parameter or inverse hybrid parameter. Okay. In case of G parameter, I1 V2 in terms of V1 I2. So it will be G11, G12, G21, G22, V1 and I2. Okay. Now see, these are the 6 parameters. So now, if suppose in case of Z parameter, if you have to calculate Z parameter means value of Z11, Z12, Z21 and Z22. So then what will you do? If you make I2 0, okay, if you put I2 0, then you can find out Z11 and Z21 from this equation, is it? So if Z12 is, if I2 is 0, that means this and this is 0. So now, if you are having I1, V1 and V2, value of these 3, then you can calculate Z11 and Z21. Similarly, if you make I1 0, that means this and this will be 0. Okay. In that case, you can easily calculate the Z12 and Z22. Okay. So that means for calculating elements of Z parameter, you have to equate I1 and I2 as 0. Okay. Once you will do I1 0, then you will do I2 0. Okay. That means, and if you are making current at input and output port as 0, that means you are what you are doing? You are doing that you are opening the input port and you are opening the output port. That's why they are called as the open circuit parameter. Okay, once if you are doing I2 equal, if you are equating I2 to 0, that means output port is open, and once you are equating I1 to 0, that means input port is open. Okay, that's why they are called as the open circuit parameter. Okay, second one is the short circuit parameter. So in case of short circuit parameter, V1 V2 are involved here. Okay, so if you make V2 0, okay, so see, if you are doing that V2 equal to 0, V2 0, that means output port is short circuited. Okay, then you will calculate these two, Y11 and Y21. Then you will do V1 to, you will equate V1 to 0. Okay, V1 0 means input port is short circuited. That's why they are called as the short circuit parameter. Okay, so ABCD parameters are also known as transmission parameter. Why? Because they are used in modeling of the transmission lines. Okay, and see here, V1, I1 are expressed in terms of V1, V2 and minus I2. That means input current and input voltage. That means sending end voltage and sending end current are being expressed in terms of receiving end voltage and receiving end current. So that's why these parameters are used for modeling the transmission lines, and these are the constants ABCD. That's why they are known as the ABCD parameter or transmission parameter or generalized circuit parameter. Okay, so similarly with the name of inverse transmission. And why hybrid parameters are there? So hybrid means, see here what we are doing, one is voltage, one is current, and if you equate V2 to 0, okay, if you are equating, if you are calculating H11 and H21, then you will have to make V2, you need to do that V2 should be equal to 0. V2 0, that means output port is short circuited. Okay, and once you have to calculate this H12 and H22, that means I1, this should be 0. Okay, so once you will make V2 equal to 0, that means output port is short circuited. Then you will make I1 equal to 0. I1 0 means input port is open circuited. That means once you are opening the input port, and then you are short circuiting the output port. That's why they are called as the hybrid parameter. Okay, so this is the term that I have already discussed, that Z parameter of two-port network. Here V1, V2 will be expressed as a function of I1, V1, V2 will be expressed as a function of I1 and I2. So now if you make I2 equal to 0, that means Z11 is V1 upon I1. Okay, I2 0 means output port is open circuited. Okay, so I2 is 0, so then Z21 is V1 upon I1. Okay, so then these terms are having individual name. So Z11 is the driving point impedance when output port is open circuited. Okay, so it is also called as the open circuit input impedance. Z11 is the driving point impedance or open circuit input impedance. Okay, similarly Z21 is the transfer impedance. Okay, transfer impedance with output open circuited. Okay, so similarly Z12 and Z22. So Z12 is the transfer impedance and Z22 is the open circuit driving point impedance. Okay, so these are the names of these four Z parameter elements. Okay, so now if you try to represent these equations in circuit, so V11, if you write V1, what is the equation? V11 is Z11 I1. So what we will write? V1 is Z11 I1 plus Z12 into I2. Okay, so if V1 is Z11 into I1 plus Z12 into I2. Okay, so this is the equation. This is the circuit which is representing this equation, and then V2 equal to Z21 into I1 plus Z22 into I2. Okay, so here each element is representing the voltage. So Z22 into I2 plus Z21 into I1. Okay, so see this Z11 into I1, Z22 into I2. Since this I2 is in this part, okay, so that's why we are representing this as the current dependent voltage source. Okay, so here also if you see this equation, V2 equal to Z22 into I2. I2 is in this part, but I1 Z21 into I1. So I1 is the current in this circuit. That's why we are representing this with the current dependent voltage source. Okay, so this is the equivalent circuit for the representation of two-port network in terms of Z parameter. Okay, so this is the representation equivalent circuit of two-port network in terms of Z parameter. Okay, so now this is the example shown here. Here question is that find Z parameter of the network that is shown here. Okay, so here you need to calculate the Z parameter. See, in this circuit capacitance has been shown and inductance has been shown. So it will be easy if you transform this circuit in S domain. Okay, so first you will have to transform this circuit in S domain because this is representing the capacitance and this is the inductance. Okay, so now the circuit has been transformed in S domain. So this is 1, it will become 1 by 2s and it will be S. Okay, so this is the circuit. Now since these two are in parallel, so you can draw the equivalent of this also. Okay, so here equivalent of this will be, see, this is the 1. Okay, so now this is S plus 2, S plus 2. Okay, because these two are in series. So now these two are in parallel. So now this is the network. Okay, so 1 upon 2s and parallel 1. Okay, so it will be 1 by 2s plus 1. Okay, so this is V1, this is I1. Okay, so this is I2 and this is V2. Okay, okay, so 1 by 2s parallel 1, it will become 1 by 2s plus 1. So now what is Z11? Z11 is V1 upon I1 when I2 is 0. So when I2 is 0, you can write when I2 is 0, there is no meaning of this S plus 2 impedance. Okay, so you will have to write equation in this part, 1 into I1 plus 1 upon 2s plus 1 into I1 equal to V1. Okay, so that means V1 upon I1 will be 1 plus 1, it will be 1 plus 1 upon 2s plus 1 equal to V1 upon I1. So this is the Z11. Okay, so this is the Z11. So Z21 is V2 upon I1. Okay, so V2 upon I1, what is V2? Here I2 is 0. Okay, I2 is 0, that means V2 is, what is V2? V2 is 1 upon 2s plus 1 into I1. Okay, simple. So what is V2 upon I1? V2 upon I1 is 1 upon 2s plus 1. And this is when I2 is 0. Okay, this is when I2 is 0. That means you have calculated two parameters. Now simple. Again, you will make I1 0 and you will do KVL case in this part. Okay, in the output port part. So here what will be the V2? V2 equal to S plus 2 into, again, S plus 2 into I2 plus 1 upon 2s plus 1 into I2. So you will calculate Z22. And then what is V1? I1 is 0. That means V1 is 1 upon 2s plus 1 into I2. Okay, so simple. So you have calculated Z parameters. Okay. So this is the another example that you can see here. Here Z parameter is to be calculated for the given network. Okay. So simple, you can calculate here. Since here impedance and capacitance are not shown, only resistance is there. So circuit, if you transform the circuit in S domain, there will be no benefit. So you will keep the circuit as it is, because inductance and capacitance are not being shown. Okay, only resistors are there, inductor and capacitor is not there. So in this circuit itself, you will have to do the KVL. So first, what is our target? That you will have to write V1 in terms of I1 and I2. So if you see here, you can write V1 equal to 3 into I1 minus 2 I3. If you write equation here, see, I2 is the current here, I1 is the current. So in this mesh only, you have to assume a current. So in this direction here, I3 current has been assumed. Okay, so if you write KVL in this mesh, so what you will write? 1 into I1 plus 2 into I1 minus I3 equal to V1 in this mesh. Okay, in this mesh, you have written the KVL equation. So this is the equation. So it is 3I1 minus 2I3 equal to V1. Okay. So now in this mesh also you have to write the equation. Okay. So V2 equal to 2 into I2 plus 2 into I3. Okay. So in this mesh, then in the you will write the KVL in the third mesh also. Okay. So minus, see, if you write the KVL in this mesh, so 1 into I3 plus 2 into I3 minus I2, okay, plus 2 into I3 minus I1. This is the second equation. Okay, so now we will have to write equation here also. So what is the equation in this mesh? So it is V2 equal to 2 I2 and I3, both are there in same direction. So these are the three equations that are written over there after simplifying. Okay, so now I3 is the current that was not there in the circuit. So if you write I3 in terms of I1 and I2, so it will be this. Okay, so now in the place of I3 in these equations 1 and 2, you just keep this value. So you will be having V1 and V2 in terms of I1 and I2. So here V1 is having I1, but this I3 is the extra term. And here V2 is there with the I2, and this I3 is the extra term. So I3 you will write in terms of I1 and I2 here. So that means you will be having equations of V1 and V2 in terms of I1 and I2C. So these are the equations finally for V1 and V2, and these coefficients are the Z parameters. So Z11 is 11 by 5, Z12 is 4 by 5, Z21 is 4 by 5, and Z22 is 6 by 5. Okay. So similarly, Y parameters means you can write I1, I2 in terms of V1 and V2. Okay. So as we discussed in case of Z parameter, so current I1 and I2 can be written as a function of V1 and V2, and you have to calculate these parameters Y11, Y21, Y12 and Y22. So one by one you will do voltages as 0. If you equate V2 to 0, that means output port is short circuited. Okay, so you will calculate Y11 and Y21. So Y11 is the driving point admittance. Okay, Y11 is also known as the driving point admittance. Okay, Y21 is the transfer admittance. Okay, similarly, when you will make V1 to 0, that means input port is short circuited, then you can calculate Y12 and Y21. Okay, so Y12 is the transfer admittance and Y22 is the short circuit driving point admittance. Okay, so now these two equations can be represented in circuit also. Okay, so I1 is y11 v1 plus y12 v2, and I2 is y21 v1 plus y22 v2. So see, these terms are representing the current. So here I1 is this is the voltage drop here. So I1 is y11 into v1 and y12 into v2. Okay. So similarly, I2 is y22 into v2 and plus y21 into v1. So this is the equivalent circuit for the two-port network in terms of y parameter. Okay. So we are representing the two-port network in terms of y parameter here. See, this is the question that is given here. So here you have to determine the short circuit admittance parameter for the given network. Okay. So in the same way as we had proceeded in the earlier question, you can proceed in this question also. Okay. So what you will do, you will first transform the circuit from T domain to S domain, because capacitor and inductors are there. Okay. So now you will have to write I1 and I2 in terms of V1 and V2 by simply applying KCL, KVL. You can do this as we did in earlier example. Okay. So this is there are few questions that are given in this slide. Okay. So for your practice. Okay. So this is for the T parameter. Okay. So this is the example of the question. Question is given for calculating the T parameters. I had already discussed these things. Okay. So no need to go into detail for this. Okay. So you just remember the name of different parameters. Okay. A is the reverse voltage gain, C is the transfer admittance, B is the transfer impedance, and D is the reverse current gain. Okay. So then this is the question. Okay. Simply what you have to remember, that in which parameter what are the dependent variable and what are the independent variables. This only you should remember. Then in the given question, you just see if there are inductors and capacitors, then you just transform the circuit from T domain to S domain. Otherwise, for this given question, there are no inductor and capacitor. So you just keep this circuit, and only you will have to keep in mind that what parameters you have to calculate. You need to calculate the transmission parameter. That means you will have to write V1, I1 as a function of V2 and minus I2. Just this you should remember. Okay. Then you just apply basic concept for the network analysis, that KCL and KVL, and write the voltages and currents, and you just manipulate the equations. You will be having the answer. Okay. So these are the few examples that are given here. So you just go through this. Okay. So this is similarly, this is for the hybrid parameters, and this is for the inverse hybrid parameters. So these things I have already discussed. Okay. So this is for the inverse transmission parameter. Okay. So just you have to remember the terminology, or you can say there are this nomenclature. You will have to just remember that what is A inverse, what is C inverse. Okay. What is A, what is B, and just calculate this. Go through the given examples, and for any query, you just feel free to contact me. Thank you.